This is the solution for the mock exam for unit circle and non-right triangles. Number 1, the diagram below shows a circle, center O, with radius r. The length of arc ABC is 3 pi centimeters and angle AOC equals 2 pi over 9. Find the exact value of r. Okay, so in this case, it's a little bit backwards because usually you have r and then you might find the length of the arc. But in this case, they're giving you the length of the arc and you're going to find r. Either way, not difficult, right? Go to the formula sheet and find the equation for arc length, which is L equals r theta, where theta must be in radians because this is the formula using radians theta. Okay, so what we're going to do is we're going to put into L the length of arc that they gave us, which is 3 pi, and then we're going to leave r as r, and then we're going to put the theta they gave us, which is 2 pi over 9, conveniently already in radians, because remember, the formula L equals r theta only works for radians. If you get a degree value, you need to convert it to radians first. Now all we're going to do is we're going to just solve for r. The pi's cancel out, so it's kind of convenient that the length of the arc had pi in it. And then we multiply both sides by 9 halves. So we get 9 halves times 3 equals r. And that would be equal to 27 halves, which is equal to 13.5. Didn't even need the calculator for that one. 13.5 centimeters. Find the exact perimeter of sector OABC. So OABC would be OABC. Be careful because usually when we look at a sector, we do things like find the area, and this is asking us for the perimeter. So to find the perimeter of this piece of a sector, we actually want to find the lengths of all these green lines. So for example, 2 of the green lines, this one and this one, are length r, right? So it would be r plus the arc length ABC, which we already know is 3 pi. And we know that the r is 13.5, so basically it's 13.5 plus 13.5 plus 3 pi, so that would be 27 plus 3 pi. And so that, since they want the exact value, we shouldn't convert pi into 3.14159 blah blah blah. We should leave it as pi, so our answer is going to be 27 plus 3 pi. Okay, and number 2. In a triangle ABC, AB equals 4, AC equals 3, and the area of the triangle is 4.5 centimeters squared, find 2 possible values of the angle BAC. Okay, so I like to draw a picture whenever I have a problem like this. And let's see, AB is 4, and AC is 3, and the area of the triangle is 4.5. Okay. Find 2 possible values of the angle BAC. BAC is this angle here. Okay? And when we talk about area, there's only one formula that we worked with in this unit for area. It's A equals 1/2 AB sine C. One thing that's confusing is that in this particular formula, we use the letters A, B, and C. And in the drawing, we already have A, B's, and C's also. And in this particular drawing, do you notice how we're looking for the angle A and not the angle C? So let's rewrite this equation into a form where the angle is capital A instead of capital C, just so that it's not as confusing. So all we need to do is convert the big C into a big A, and then the small a and small b become small b and small c. So now let's look at it. So we know that, oh, and it's kind of confusing also that I'm using capital A for area. So I'll just write area here. So the area is 4.5. They gave us that. And then we know that 2 of the sides are 3 and 4. So we're going to put those in for B and C. Those are the 2 sides that are adjacent to the angle that we would like to know, which is capital A. So we do not know that yet, so we'll leave it as capital A. So we know that 4.5 equals 1/2 times 3 times 4 equals times sine A. That is equal to, let's simplify 1/2 3 times 4. 3 times 4 is 12. 12 divided by 2 is 6. Now we could solve for sine A. Sine A is equal to 4.5 divided by 6, which looks like it's going to be like 0.75. And then we're going to have to find the inverse sine of that. So yeah, 4.5 divided by 6 is 0.75. The calculator's in radian mode, so I'm just going to do it in radians. So I'm going to do inverse sine of 0.75. And that gives me 0.848 radians. Okay, so that is one possible angle A. The other possible angle A, and remember 0.848 radians is in the first quadrant. Okay, remember 1 radian is about 57 degrees. So, and the other angle, which has the sign of 0.75, positive 0.75, would be the reflection into the second quadrant. So that would be equal to 3.14 minus 0.848, which would be equal to, let's do pi minus 0.848. And it would be 2.29. So that would be the other angle. So there's two possible angles, they said, that have a sine of 0.75. It would be 0.848 radians or 2.29 radians. And if you want to convert that in degrees, you can. But in this one, they didn't really say if you want the angle in degrees or radians, so you don't have to. To convert it, I would take 0.848. I would multiply it times 360 and divide it by 2 pi. 2 pi, which is 6.28, not 6.8. 48.6 degrees. So that would be the degree version of 0.848. And then to find the supplementary angle, which would also have the same sine value, it would be 131.4, something like that. Okay, so those would be the degree versions of your answers. Okay, all right, let's go to the next page. The diagram below shows a sector AOB of a circle of radius 15 centimeters and center O. The angle theta at the center of the circle is 2 radians. Okay, so that's 2 radians. Calculate the exact area of the sector AOB. So now we are finding a sector. So remember that the sector formula is area equals 1/2 theta r squared, which is equal to 1/2, and the theta in this case is 2 radians. And remember, this formula is made for radians, so you must have a radian input, and they gave us that the radians is 2, so we just put 2 in there. And the radius, do we know the radius? Yeah, we do, it's 15. Okay, so 1/2 times 2 is 1. 15 squared is 225. So the area is 225. And that's it for A. Now let's calculate the area of the shaded region. Okay, so the shaded region basically is the yellow region minus this triangle. So what we need to do is figure out the area of that triangle. There's a couple ways to do it. The way that uses what we learned in this unit is it uses the 1/2 AB sine C formula to figure out the area of a non-right triangle, right? And in this case, the angle sine C is 2 radians, right? So it'd be the sine of 2 radians. And then AB would be the radius of each one, which is 15, and then times 1/2. So that would be equal to 1/2 times 225 times the sine of 2 let's put that in the calculator. 0.5 times 225 times sine 2, which is equal to 102.3 degrees. I'm sorry, 102.3 centimeters squared. And that is the area of the red triangle. Okay? Now what we want to do is we want to take we want to find the difference between the yellow pizza piece minus the red triangle. And that would give us the shaded arc, not the shaded arc, the shaded, I don't know, orange slice. Okay? So what we would do is we would take the 225, which is the entire sector, and we would subtract 102.3, which would give us 122.7. You could put 123 if you round to 3 singular figures. Okay, next page. There is a vertical tower, TA, of height 36 at the base A of a hill. A straight path goes up the hill to a point U. This information is provided in the following diagram. The path makes a 4-degree angle with the horizontal. What that means is this angle here is 4 degrees. The point U on the path is 25 meters away from the base of the tower. The top of the tower is fixed to U by a wire of length X. Complete the diagram showing clearly all the information above. Okay, so 4 degrees would be this angle here, 4 degrees with the horizontal. The point U on the path is 25 meters away from the base of the tower. So the base of the tower is A, and U to A is 25. The top of the tower is fixed to U by a wire of length X. Okay. So we're done with part A, which is to make that diagram. Find X. Okay, so X looks like it's one side of a triangle formed by two sides 36 and 25. So we know 2 of the 3 sides. We don't appear to know any of the angles, but we do know this angle 4 degrees right here. We know that the 4 degrees is with the horizontal. We know that the tower TA is vertical. So we do know that this here is a right angle, which means that the angle UAT is going to be an angle of 86 degrees, right? Because it would be the complementary angle with 4 degrees. 86 and 4 should add up to 90. So now we know enough information, which is we know that one side is 36, one side is 25, and the included angle is 86 degrees. Can we use law of sines, which is usually easier to use? Sine rule. We cannot use sine rule because there are no side angle pairs that we know both the side and the angle. So we're forced to use law of cosines, which is sometimes a little bit more difficult, but this is a calculator test, so not so bad. So let's write down the cosine rule. And there's 2 cosine rules. There's one that looks like this. 2ab cosine c, something like that. And then there's one that solves for cosine c on the formula sheet. I don't really have that one memorized, but if you write that one down, that is more convenient when you're looking for an angle. Now in this particular case, are we looking for an angle? No, we're looking for a side. So in that case, we're not going to use that one. We're going to use the traditional one that is arranged like this. And so let's fill in what we know. First of all, do we need to rewrite this with other letters? No, we could just relabel everything up there using ABC. Okay, so let's say that 86 degrees is our big C because it's the only angle involved in the problem. Our X is going to be small c, and so that means that 36 and 25 can be A and B. So let's fill everything in here. So c squared is x squared. A squared is going to be 36 squared. B squared is going to be 25 squared. And then it's going to be 2 times 36 times 25 cosine of big C, which is also 86 degrees. Okay, so now we could just type this whole thing into the calculator. And let's put our mode into degrees because we've done everything in the radians so far. And this problem gives us an angle in degrees, so it's easier if we change the calculator to degree mode. And then we just type everything in. 36 squared plus 25 squared minus 2 times 36 times 25 times cosine of 86. Calculator is expecting degrees because we put it in mode degrees. And the answer here, and it's not the answer, but it's an intermediate result, 1795 is equal to x squared. And so then we just need to take the square root of that to find the x value, which is the length of that wire, 42.4. And we're done. Okay, I think that's it for this page. Yes. Next, okay, we can write down the answer here. Let's go to the next page. Number 5. The diagram shows a vertical pole PQ which is supported by 2 wires fixed to the horizontal ground at A and B. A lot of people have trouble understanding this diagram. Basically, there's a floor here, which is this. It's a floor. And then the rest is like a tent. There's like this vertical pole, and the rest of it is like, you know, tent roof and flat sides. Okay? So basically, the yellow triangle has 2 of the angles marked, which is the 70-degree angle, and the way they drew this is like really bad perspective, so it makes it look like the 70-degree angle is something else, but actually it's the angle on the floor, and then also 30 degrees. But this is the original IB diagram, so you're going to have to understand what they meant, okay? Okay, so they give us a lot of information here, which is basically repeating information in the diagram, but it makes it a little bit more clear, right? So like you can see that the 70 degrees actually corresponds to BAQ, which is the angle on the floor, even though the way they drew the circle, this arc here, makes it look like something different. Okay, so they labeled all these directly on the diagram also, which is helpful. Find the height of the pole PQ. So first we want the height of this pole. And basically, to find the height of this pole, since we know that BQ is, oh, they didn't label that the BQ is 40. This line here is 40. So with this length and with this angle, we can pretty much find, and the fact that that's 90 degrees, we can pretty much find that post length, right? This is a pretty basic SOHCAHTOA problem, right? So we got 36 here, 36 degrees here, we got 40 here, and we have this unknown length. It's SOHCAHTOA, right? Would it be SO, CA, or TOA? In this particular case, we're talking about an angle where we know the adjacent side, we don't know the hypotenuse, and we'd like to know the opposite. So this would be a TOA problem. So tangent equals opposite over opposite over adjacent. So it would be let's say that the post height is y. We're going to put opposite over adjacent. The tangent of 36, our calculator is still in degree mode from the last problem. Tangent of 36 is equal to 0.727. And so basically to find y, we just multiply both sides by 40. And I get 29.1 degrees. Or not, 29.1 meters. Yeah, meters. So y is equal to 29.1. And then it asks us to find the distance between A and B. So the distance between A and B is also a length of one side of the floor. And what is helpful, I think, is to draw the floor triangle out flat. And we can see that this angle here is 70, and then this angle here is 30, and this angle here is not a right angle, okay? And then we can label this side 40, length 40, and this side we want to know what it is, and this side we don't know what it is either. So the side that we want to know what it is, let's label it Z. Okay, and then we'll figure out what non-right triangle rule we can use to figure this out. Do we know a side angle pair? Yes, we do. 70 degrees is opposite 40, so we can use law of sines here. Okay, so if we use law of sines, then we're going to either put the sines on top, or like we could put sine big A over small a equals sine big B over small b, or we could put small a over sine a equals small b over sine b, whichever one is more convenient. We're looking for a side value. Since we're looking for a side value, it's more convenient to have the sides on top. So we're going to use this version of law of sines. Then it's less algebra. Okay, so let's rewrite it. We're going to put, first of all, 40 and 70 degrees in for small a and big A. So that would be 40 on top and sine of 70 degrees on bottom. And then small b and big B, we're going to fill that in here. Small b would be our z value, and big B would be this angle. So small b would be z. We don't know what it is yet. Big B, we don't know what it is either, but we do know that the other two angles of the triangle are 30 and 70, which add up to 100, so that means that B must be the supplementary angle for 100. 180 minus 100 is 80 degrees, so it would be sine of 80 degrees. So now we know that Z must be equal to 40 divided by sine of 70, and sine of 70 is something like 0.940 times sine of 80, which is 0.985. And if we multiply all those out, we'll have 0.985 times 40 divided by 0.940, which is that one. Notice how I was able to keep all the digits by using copy and paste. And so the result is 41.9. So I just write that here. And we're done.